give you the cess and stain regarding that. Okay, first from beginning I will start now. Let me open that one. Yeah, this is the ANSYS project page or workbench window project page. In the workbench, this is the project that we will be calling. These are analysis systems. These are component systems. Okay. Now I'll save this file first. Okay, I am doing the structural analysis. Okay, I'll drag and drop structural analysis here. Okay, then I will go into the engineering data. Okay, I want to add the aluminum material properties. By default, ANSYS will be going with the structural steel. Okay, I will click on the engineering data sources. In that one, there are libraries, different data sources are there. I click on the general materials. Okay, in that one, I want to add the aluminum. Aluminum, I need to click this plus mark where it will be added into the your workbench window. You can just close this engineering data. And geometry, I want to import the geometry. Import geometry, browse. Okay, this step file I am using that one. Okay, I will come back to the model. I imported the already geometry. You can see the progress here in the bottom. Okay, it has imported the geometry now. You can see right, this is the hexacopter. Okay, first we'll check the what are the different. When you click on the geometry, there is a details of the geometry in the below. Okay, you can check the properties. Okay, what is the mass? Okay, what is the volume? Okay, these kind of things you can check. Okay, and you can see the bounding box. Everything can be checked here. Okay, each part you can see there is a structural seal has been assigned here. Okay, by default it will assign. If you need to change, then you need to go here and change that one. Aluminum alloy. Okay, let us consider you have forgot to add the material in the engineering data. That is here in the workbench. You forgot to add the material data. You open the mechanical. Then what you can do is you just click here. You can search here. Okay, that will be coming here. You can use that. That one is also possible. Two ways are there. Okay, and whenever you imported the geometry, like if you want to simplify something, okay, that can also be done using the space climb. I will show you some of the like what are the operations available here. Okay, I'm not carrying out any live demonstration for that one. Some of the options available, space claim, okay, which can help you for the simulation. Okay, I can show you that one. Okay, first now you can check here. Okay, these are some of the tabs available. Design. In this one, design. Okay, there are sketch models like same your 3D modeling, however you are doing. Okay, right? Okay, I'll show you. Okay, these are some of the sketch. You can sketch plane. You can select. Okay, use and sketch something. You can give the dimension. Same thing you like 3D so modeling softwares you will be using pull and push. Okay, whatever you are doing, can do that part. Like whatever you are interested, you can do. Okay, same way like move. These are some of the okay, the 3D modeling available for you. Okay, you might have done 3D modeling in the other software. If you want to carry out the 3D modeling here also it is possible. Okay, all the options available here as you can see here. Okay, next one is you can have the assembly. Okay, where so you can add the some of different parts and make the assembly. That's also possible. Assembly option, tangent, align. Okay, this move tool, using move tool you can use all the options available in the assembly. The next one is regarding the facets. Okay, whenever you are having some STL files, okay, I think you know the STL files, right? Whenever you are doing some analysis in the static structural or structural, okay, you want to like export whatever the deformed geometry is that you exported the deformed geometry, it will be in the form of STL. That is mesh file. Okay, then if you want to refine that one, that mesh files, you can use all the options available here: clean up and skin surface, shrink wrap, everything you can use that one. And next one, these repair and prepare. These two are more important for the simulation purpose of it. Okay, whenever you import some bodies, there will be some loss of data. If some geometries are there, they are not perfect. Then you can use these options. First, we have to start with stitch. If there are any gaps between, as the icon suggests, if there is any gaps or like that, it will stitch that gap. It will give you the new face there, gaps and missing faces. These three tools are really helpful. Okay, next one is split edges. Okay, whenever there will be some geometries where it will be like in this case there is only one edge is there. Okay, but in some geometries there will be split. Okay, there will be so for a single edge there will be like one, two, three, four edges will be there. Okay, this will cause the problem because whenever you are doing any analysis, okay, it starts with edge, then it will go to the face, then it will go with the volume. Okay, whenever edge size is really small. Okay, then you might have thought this edge size is somewhere around 57. Okay, you may have given the mesh sizing as 10 mm. Okay, but complete this one is 57, but there might be some edges on that one, small edges will be there which is having a dimensions lesser than 10 mm. Okay, those will be causing error to do the meshing. Okay, to address those kind of things you can use the split edges. Okay, if the faces, small faces are there, we can use the merge faces. These kind of things, all the things can be done. Okay, now and mid surface extraction, as you can see, where the simple mid surface if you want to extract, that can is also possible. Okay, I extracted mid surface. I will be going to do the cell meshing on this one. Okay, and do the analysis for the thin bodies. We can do these kind of things. Okay, then these are some of the, if you are having the assembly, then there is interference. You can check with this tool, and if there are beams, if you want to extract any beams elements. Okay, mid surface I have showed you, shell modeling I have shown you. Now beams, regarding the beams, or if you want to extract any beams, that's also possible. Okay, beam is extracted like that you can do. These are some of the options available with that one. Okay, then I'll come back to the mechanical. Okay, first I'll select every body and assign as aluminum. Okay, I have assigned it to aluminum. Now you check the geometry properties. It was 7 kgs that time. Okay, now it is 2.545 kg now. Okay, three times the mass has been reduced since the density is three times lesser than the steel. Aluminum's density is three times lesser, right? Okay, now like whatever the material you will be adding here, you can see in the material. If you click on the on that material, what are the properties there with respect to that material, you can check here. Okay, now with the connections, you can see. Okay, it has already created the connections. Okay, now it is saying as contact region 1, 2, 3, 4. You might not be getting like why with to which part it might have connected. Then you click here and rename based on definition. Okay, then you can see like what are the different, what is the type of contact and what are the parts attached. These names will also be coming. Okay, since it is linear analysis, we are not considering any non-linear contexts. Okay, we are going with this context. You can check here. We are going with this context. The next one, I want to insert some of the sizing. Okay, that is, I want to insert for the complete body. I want to insert the sizing. I'll just select one of the body. Then this option, select all. Okay, selection, apply. Okay, then you can see sizing, it has been turned into the body sizing. Default, it is saying as 56.06076. I want to change it to the 4 mm. Okay, now I'll click and generate the mesh. Okay, now you can see it has been meshed now. Okay, where and regarding the meshing, you always remember that ANSYS always try to mesh with hexagonal elements at the first to all the geometries if possible. If he is not able to mesh with the hexagonal element, then it will go with the tetrahedral element. So you can see here, these are all hexagonal element. This one, this one, this one, this one. Okay, this one, this one, this one. Everything is hexagonal elements. But if it is not possible to mesh with the hexagonal element, then it will go with tetrahedral elements. You can see now here, here. Okay, these small parts are there. It will go with tetrahedral elements. Okay, and I was explaining during the slides, I was explaining element order, that is linear and quadratic, right? Here you can see by default ANSYS will be going with the, this is program control. By default, it will be going with the quadratic elements. How to verify that one? I will go for the this node selection. Then I'll go here. I'll check for the mid-side nodes. You can see all the mid-side nodes are present here. Okay, mid-side nodes are present. Okay, you can say that now it has gone with quadratic only. By default, it will go with quadratic. Okay, if you want to change, that's also possible. You can use linear here, and it will mesh with the linear elements. Okay, when you click on the mesh, it is at the statistics. You can check what are the different kind element count. Like nodes is somewhere around 3,45,000, and elements is 1,18,000. Okay, since it is linear analysis, we are not much concerned about this node count. But whenever you are doing any non-linear analysis where the convergence issue and are not are expected, in those cases, it is better to limit the element and node count within the 1 lakh. Here, we are not concerned about that one since it is a linear analysis. Okay, now regarding the how to check the mesh quality. Okay, and I will show you in the best practice. I have the graphs and I will show you here also. You can check, you can click on the quality. Okay, mesh metric, element quality, it will show you the graph. Okay, elements above zero point 0.2 and or above, like zero point 0.2 and above is all acceptable. And you can see here tet 10 x 20 wedge 15. Okay, tet 10 means 10 noded tetrahedral, 20 noded hexahedral, 15 noded wedge. These are all quadratic elements only. Okay, then you can check these kind of things. Okay, tet hexa, it will for red color, and this is green color. Okay, everything can be seen here. Then if you click on the any graph here, I'll click on this graph. So where are these elements? Where these elements are located? It will show like that. Okay, like here in this case, I'll click here. If I click here, where are these elements are there? Huh? Where these are situated? Okay, it will show those kind of things. And if you want to give any some like what you call controls here, you want to have the good quality of mesh, you want to move these whatever the towers are there towards zero point 0.2 and above. Okay, then you can give the some of the controls here. Just mention some of the controls. Okay, it will mesh. After that, you can come back and check here quality again. Okay, okay, this is regarding the element quality. Okay, now I'll go back to presentation. You can check here. Meshing is done, contact is done, and thrust load is, they are saying 60 Newton at each motor, and payload is 118 Newton. Okay, now I'll go back to mechanical. First, apply force. Okay, always, okay, always consider downward direction for the, okay, this whatever the payload is there, 12 kg, that is 118 Newton. Okay, I will be considering uniformly distributed on on this face. It has been uniformly distributed on this one. I will apply. Okay, in the force application, I will change the vector to the components. Okay, now you check for the direction. It's minus 118 Newton of Z component. Okay, minus 118 Newton. It has been checked now. 118 Newton force has been applied here. Okay, now I want to apply the thrust force also. And for thrust force, I will be applying on the motor surfaces. Okay, let me hide this one. No, no. Hide body. On this area, I want to apply the thrust force. Okay, I'll select this face. Okay, but manually selecting all the six faces is really like I have to hide all those parts and manually I want to go. Then I can use the name selection. In the name selections, what we can do is we can select the faces having the same cross section area. If the cross section area of the other five motors are same, then it will be selected. Let me check that one first. Okay, right click and create name selection, and I'll use the second option and give some name as uh, payloads. This is regarding thrust, right? Thrust force. Okay, and I am saying a same size. Okay, same size, type eyes. Okay, let me go back in the name selection, check how many faces are there. Okay, it has selected the six faces. Okay, six faces, we can identify which one are there. Okay, you can see here it has selected. Okay, here also it has selected. Here also it has selected. Same way, total on the six faces it has selected. Okay, now I'll include the force. Insert, again force. Now I'll change this geometry selection to the name selection, and whatever the name selection we have created, it will be appearing in this drop down thrust. Okay, then I want to apply with the components. Okay, that is nothing but plus Z 60 Newton. Okay, I think including all the phases it will be 360 Newton. Okay, 60 at each. Okay, other if you apply say 60, then it will be divided into these like uniformly divided on the all the faces. Okay, then I applied force. Now insert. Like whenever you are doing any structural static analysis or dynamic analysis, there should be one what you call support. Okay, otherwise, let us consider this body is there already. Okay, 1 minute. If you don't apply any fixed support, whenever you apply force, okay, this body will be moving out. Okay, moving in the space. It's like a rigid body motion. It doesn't have any constraint. Okay, that's why there should be at least one structural load, at least one constraint should be there for solving any analysis. That's why I will add fixed support. Okay, fixed support. I will use these whatever faces are touching to the ground. I applied